like we have to learn that how to write these, write the differential equations for the given situations, okay? Avi says, write the following as differential equations, do not solve the equations. Now, can you see these questions on your screen, Bacho?
Yes, sir.
Okay. Now it says for height h and time t, the rate of decrease of the height of water. Now this is the rate of decrease of height. So that has to be taken as dh by dt. That is the rate of height, the rate of change of height basically. If it is decreasing, so you will put that equal to minus, okay, na? You have learned about the rate of change of x that you were calling, writing it as dx by dt, the rate of change of y, that was dy by dt. Okay? So now it says the rate of decrease of height of water. So that is dh by dt. And it says it is proportional to the square of the height, is proportional. So I have to use the sign of proportionality over here, and that is minus h square. Okay, so you will start writing it like this: dh by dt is proportional to minus h square. Now please see, this minus is because of this decrease over here. You are saying there is a decrease, okay? So to cater this decrease, we have to put a minus here, and then later this equation can be written as, like when you put the equal mark here instead of this proportionality, so that will be equal to minus kh square. That is minus kh square. Now for the second question, the rate of increase of the number of infected cells. Now this is the n is the number of infected cells, t is the time over here. So the rate of increase of these cells, so that will be dn by dt, and that is proportional to the number of infected cells, so that is proportional to n. Okay? And then you change this into the equation mark here in equation style. So this is going to be dn by dt, that is equal to kn. So this is the differential equation that has been obtained from this given statement of part B. Okay? Similarly, if you look at the C part, the rate of decrease of the velocity of a particle moving in a fluid, the rate of decrease of velocity. Now this is the rate of decrease. Look at this decrease thing over here, and the velocity is represented by this v. So I'll be saying that, okay, this dv by dt, that is going to be proportional. This is proportional, and I have to put a minus here because it says decrease, okay, to the product of v and v plus 1. This is v into v plus 1. And then when you change this proportionality sign with the equal mark, so the equation would look like this: dv by dt, that is equal to minus kv into v plus 1. Okay? Can you try the remaining three parts? Please try them. Similarly, for this last one, for speed v and time t, the rate of change of speed of a skydiver just after he jumps, so that is inversely proportional to e raised to power t over 2. So this dv by dt, that is proportional to 1 over e raised to power t over 2. Now first time we have seen this inversely proportional thing over here. This is inversely proportional. So that actually means when you have, like if you people recall your O-level things, that if y is directly proportional to x, we write it like this. And when y is inversely proportional to x, we write it as y is inversely proportional to 1 over x. Okay? So this dv by dt is inversely proportional to e raised to power t by 2. And then this dv by dt will be equal to k times, and you can also write it as k times minus e raised to minus t over 2. Because if you switch this to the numerator, this power sign becomes minus. Okay. Okay, in question number 2, it says a large tank is full of water. The tank starts to leak. T seconds after the tank starts to leak, the depth of the water in the tank is x meters. Okay, so the depth, if we take depth as h, so that is going to be x meters. Okay, and the rate of decrease of depth is proportional to the square root of the depth. So this is dh of dt. The rate of decrease of the depth is proportional to the square root of this depth. Okay, so this is going to be like uh, this. I should, if I take this as h, I am going to write h over here. Okay. Okay, so it says, yes, the rate of decrease of depth of water is proportional to the square of the depth of water. Write a differential equation. Now it says in x, so then I should change this. I should be writing here. Oh, everything is gone. Let me draw that quickly again. Mm, This. Um, okay. Goes like this, and now this was dx by dt, that was minus k square root of x. Okay, now it says yeah, so we have the x here, so we have this we have got this x, t, and this constant, which is k. Okay? Now it says at the instant when water starts to leak from the tank. So that means when the time is 0. Okay? The depth of the water is 4 meters. So x is going to be equal to 4 meters. And then he says, solve this differential equation expressing t in terms of x. So आगे भी you were saying.
Sir, the depth, depth is 6.25.
Oh yeah, I missed that. I missed that. It says it starts, the depth of water is 6.25. Okay, so this was 6.25 meters, and then after 120 seconds, when the time is 120 seconds, now the depth is 4 meters. Now, who will tell me that, can anyone tell me that why do we have two pairs of information here? Because when you will solve this, there is already
simultaneous equations
over here, and then you will have that plus c as well. Okay, so this is going to be dx over under root x, that is equal to minus k dt. So we integrate both of them. Okay, so now you must be very good at integration. So this can be like, you know, written as like, obviously you will write this as x raised to power minus half. Okay, so this is going to be x raised to power half over half, will make it like this, 2 x raised to power half, and that is equal to minus kt, and then there is a plus c. So now we shall be using this given pair of information here to determine both k and c. So now let's put t0 and x as 6.25. So this is 2 into the square root of 6.25. That is going to give us c. The square root of 6.25 is 2.5. So c is going to be 5. Now this equation now becomes 2 under root x, that is minus kt plus 5. Now we use the second pair of information. We put x as 4. So this is 2 under root 4 that is equal to minus 120k plus 5. So this minus 120k is equal to minus 1. Therefore, your k is going to be 1 over 120. Okay. So finally, your equation is going to be, let me write it here. The equation is going to be, I'll be using this space here. So this is 2 under root x, that is t over 120, and then we have plus 5. Now he wants us to write t in terms of x. Okay, so this t over 120, that is equal to 2 under root x minus 5, and then finally this t is going to be 120 into 2 under root x minus 5. Okay, you see there are three parts. The first part is about the formation of this differential equation. The second part is the main part where you solve this equation. And third part can be of 1 or 2 marks where you have to find a certain value. It's just by the time it takes for the depth of the water to halve. So what was the actual depth? That was 6.25. So what is half of 6.25? That would be 3.125. So you find that time by the last part would be this time would be 120 into the 2 under root.
Sir,
Yes,
there's a minus as well. It's minus t over 120, so it will be minus 120 into 2 under root x minus 5.
yeah, you're right, beta. Yeah, absolutely right. This is, it is here. Yeah, this is minus here. Thank you, beta, because I just ignored this over here. It was here. I just put this k as 1 over 120. So k was, basically there was a minus over here, this minus k. Thank you very much, beta. So this is going to be minus. So this is going to be, this is going to be 5 minus, and this is 5 minus under 2 under root x. Okay, so let me just correct this. This is going to be um, so this is 5 minus 2 under root x. You really corrected us very timely, otherwise this time was going to be negative. Okay, so this is going to be, this time is going to be 120 into 5 minus 2 under root 3.125. So did anyone calculate this time? What is that time?
Sir, 176. 176 seconds.
Okay, thank you, Beta. So that is how we solve a complete question on differential equation.